Good morning, my friends. Today's lecture is about endodontics. I will now speak to you about endodontics. So please listen carefully. This information will help you in making endodontic treatment in dentistry. Röntgenography in endodontics. Röntgenography in endodontics. There are many applications of radiographs in endodontics, which are as follows. Again, I will repeat: röntgenography in endodontics. There are many applications of radiographs in endodontics, which are as follows: aid in diagnosis and localization of hard tissue alteration of the tooth. Again, I will repeat it for you to understand it. Aid in the diagnosis and localization of hard tissue alteration of the tooth, sclerosis and resorption, and periradicular structures. Sclerosis and resorption and periradicular structures. And this is the endodontic radiograph importance. Number 2, determine the number, location, size, shape and direction of roots and root canals. Again, I will repeat it. Determining the number, location, size, shape and direction of roots and root canals. Number 1, aid. Number 2, determine. Number 1, localizing hard tissue. Number 2, location and shape. Number 3, estimate and confirm the length of root canals prior to instrumentation. This happens when I want to estimate the working length of the root canal prior to instrumentation and canal removing. Number 4, determine the relative position of structures in facial or lingual dimensions. Number 5, I will repeat it for you to understand. Determine the relative position of structures in facial or lingual dimensions. In facial or lingual dimensions, we have to determine the relative position of the anatomical structures. All is that coming from the radiograph. Confirm. Number 5, confirm the position and adaptation of the filling points. Again, confirm the position and adaptation of the filling points. Number 6, evaluate and recall films the excess or failure of endodontic treatment. Again, I will repeat number 6, evaluate and recall films the successes or failure of endodontic treatment. Now, there is a question that's coming every year in the baccalaureate tests, the bachelor tests, and this test is generalized, and it will come even in the master test. And it says enumerate the röntgenography, that means enumerate the radiographic importance of endodontics and endodontic therapies. In one word or in small sentence, and you have to of course enumerate the application of radiographs in endodontics as follows. Number 1, diagnosis and location. Number 1, hard and soft tissue. Number 2, location and shape. Number 3, working length. Number 4, position of anatomical structures. Number 5, position and adaptation of filling. Number 5, filling points. And number 6, success and failure. Now let's move on to the next ideas and next flow of thoughts. Here we can see in our brains that we have to make a determination of the working length of the tooth. The working length is the distance from the incisal edge of the tooth or the tip of the cusp to 0.5 millimeter short of the radiographic apex. Again, from the cusp to 1 millimeter short of radiographic apex. So it is shorter than the radiographic apex. Always the working length, the tooth is shorter 1 millimeter of the radiographic apex. That means the working length is longer than the radiographic apex. And it is the same as the anatomical apex. Let's move on in the thought. Objective of the working length. So why we do, I will ask a student, I will ask someone to answer this question for me. What is the objective of the working length? Why do we use the working length? Why it is necessary? The working length is necessary because it establishes the length of the tooth at which the canal preparation and subsequent obturation are to be completed. Again, to establish the length of the tooth at which the canal preparation and subsequent obturation are to be completed. The apical end of the root canal in the cemento-enamel junction, which is usually 0.5 millimeter short of the radiographic apex. Sometimes the apical foramen is laterally positioned, so it would be more than 1 millimeter from the radiographic apex. Again, the objective is to establish the length of the tooth at which the canal preparation. So we have to, again, establish the working length and the working length of the tooth of the canal preparation. And the subsequent obturation are to be completed. The tooth have to be obturated. We have to complete the tooth obturation. The apical end, so if we determine the working length, we can do an obturation very clearly and everyone can be happy with the sequence of the result. The apical end of the tooth canal is the cemento-enamel junction. Cemento-enamel junction usually 0.5 millimeter short of the radiographic apex. This means the cemento-enamel junction it is very close to the apex of the tooth. 1 millimeter cemento-enamel junction to the radiographic apex, which is not very clearly shown in when we use it, but it is as it says here that the apical end of the root canal is the cemento-enamel junction, apical end of the root canal. This means that it is the beginning of the root canal. I'm not very familiar with this, but it is the apical end of the root canal. Is the cemento-enamel junction, which is usually 0.5 millimeter short of the radiographic apex. Sometimes the apical foramen is laterally positioned, so it would be more than 1 millimeter from the apical radiographic apex. And here somebody asks me, what is the meaning that the radiographic apex is close to the cemento-enamel junction and the apical foramen? And I answered that within the root chamber, root canal chamber, or the pulp horn and pulp chamber, there is an apical foramen, and it is very close to the, of course, to the cemento-enamel junction. Reference points: it is the site on the incisal edge, or what is the reference point? It is very easy to answer this question. The reference point is the site on the incisal edge or occlusal surface from which measurements are made. Usually it is the highest point on the incisal edge in anterior teeth, and the tip of the cusp in posterior teeth. It should be stable, easily visualized during preparation, and will not change during or between appointments. This is the reference points. It is at the tip of the cusp or the tip of the incisal edge. Very clearly, you will see it when you will work with the tooth. Of course, the tooth, we have first premolar, that's having one canal, and we have many numbers of branchial canals. We have the canals, main canal, of course, and we have the number of small canals. Most premolars have one canal, and molars have mesiodistal, mesiolingual, distal, distobuccal, and distolingual. That's 5 canals on the first molar. And the second molar has also mesiolingual, mesiobuccal, and the distal. Only the molar have 5, but the second molar have 3, 2 mesially, 1 distally. A procedure of working length determination. Now I will determine the working length. First, examine the preoperative radiograph and estimate the length of the tooth. Everyone should examine the preoperative radiograph and estimate the length of the tooth. Whether it's a long tooth, whether it's a short tooth, I don't know, but you have to estimate it. Then, using the radiograph, know the average length of each tooth and place the file selection to the correct initial width into the canal with its rubber stopper set at estimated working length. Again, know the average length of each tooth. Place the file selected to be correct initial width into the canal, which with its rubber stopper set at the estimated working length. Place the file selected. I will repeat this procedure for determining the working length. Examine the preoperative radiograph and estimate the length of the tooth. Then know the average length of each tooth and place the file selected to be the correct initial width into the canal, which its rubber stopper set at the estimated working length. And then number 4, radiograph the tooth to verify the position of the instrument. Number 5, readjust the file length according to the radiograph result. Results are either fit, too long or too short. Of course, you have to notice that the bisecting technique in X-ray can't measure the exact length of the tooth, and the parallel technique is the more accurate one. Some people asks me on how is the bisecting technique is not accurate because it is not perpendicular. The ray X-ray is not perpendicular to the tooth, and the film is not parallel to the tooth. This was my answer. The bisecting technique, of course, cannot be reliable. The radiographs should be repeated in the following stages of treatment to check the working length. Radiographs should be repeated in the following stages of the treatment to check the working length. We have to see the radiographs and should be repeated the procedure in many stages in the treatment to check the working length if it was right or not. Initial size. What is the initial size? It is the first instrument used to fit the working length. It has a slight resistance. This is the initial size. Is the first instrument used to fit the working length and have a slight resistance. If the radiograph results are too long, example 3 mm long, here we have to subtract 4 mm and take another radiograph. Again, some people say, what if the radiograph results are too long? And the answer, if the radiograph results are too long, example 3 mm long, we have to subtract 4 mm and take another radiograph. If the radiograph results are too short, example 3 mm short, we have to add 2 mm, then take another radiograph. Every dentist should know this, and I know it very well. Moving on, let me give you this information, and you have to think it in your mind and determine whether it's right or not. The dentino-cemental junction. What is the dentino-cemental junction? The dentino-cemental junction is the junction between the cementum and the dentine in the apical constriction of the tooth. Okay? In the apical constriction of the tooth. It is the most apical point of the working length. The root canal preparation should be limited to this junction and form a construction to prevent over-instrumentation or over-obturation. As you hear me, this is very important to know the cemento-enamel junction. I'm sorry, the dentino-cemental junction. It is the last point the instrument have to be reaching. Next, buccal object rule. When treating premolars and molars, it is often difficult to recognize radiographically which canal is nearer buccal side. So, what do we do if we cannot recognize which canal is nearer to the buccal side? If this one is nearer to the buccal side of the second mesial-buccal or mesial-buccal or distal-buccal is nearer to the buccal side. We have one lingually, one buccally, and we don't know which one is the palatal one, which one is the buccal side. So when we expose, when the exposure is done to a multi-canaled tooth, the canals may be superimposed and difficult to differentiate them. If the X-ray cone is deviated medially or distally with a given angle, the roots will separate in the film. Therefore, when the cone is moved distally, the buccal canal will appear medially to the lingual or palatal canal. So we just deviated, and because it's superimposed the canals, we deviate the cone, the X-ray cone, to move it distally, so we can see the medial canal appearing. The canal that is the lingual appear moving distally, so the buccal canal will appear. When we move the cone distally, the buccal canal will appear medial to the lingual canal, or medial to the palatal canal, the same thing. Three-dimensional imaging. What is a three-dimensional imaging? Computed tomography was introduced by Godfrey Hunsfeld, and the tomography refers slice imaging, is which thin slices of the anatomy of interests are captured and synthesized manually or using an algorithm. Cone beam CT CBCT is a relatively new diagnostic imaging modality that has been recently added to the endodontic imaging armamentarium. Again, it is which is a slice of anatomy that's captured by the synthesis manually or using algorithm. Cone beam CT is relatively new. Cone beam CT is like CBCT, not only CT. Is a relatively new diagnostic imaging modality that has been recently added to the endodontic imaging armamentarium, and it uses a cone beam instead of a fan-shaped beam in multi-detector computed tomography, MD multi-detector CT is acquiring, it's not CBCT now, it's MDCT, acquiring image of the entire volume as it rotates around the anatomy of the interests. CBCT offers relatively high resolution, isotropic image, allowing effective evaluation of root canals, morphology, and other subtle changes within the root canal system to produce faster, low cost computer compared with MDCT. So CBCT offers relatively high resolution isolated images, allowing effective evaluation of root canal morphology and other subtle changes within the root canal system. It produces faster, low costs compared with MDCT. High contrast imaging modality that could capture the information in 3 dimensions using a limited field of view. So which one is better, CBCT or MDCT? Some people say CBCT because it's with high resolution, isotropic, and root canal other subtle changes are good and faster and low dose. So CBCT is better, some people say. In the endodontic, we have to know that there are many intercanal instruments. What are these intercanal instruments? These instruments are used inside the root canal. Classification of intercanal instruments. They are divided into 6 groups. The intercanal instruments are divided into 6 groups. Group 1, manually obturated instruments such as barbed approach and K-type and H-type instruments. We use usually K-type instruments, and these are called Group 1 manual operation. Group 2 low-speed instruments with a latch type attachment. Typical instruments in this group are gated Glidden, bores and piezo reamers. They are typically used in the coronal part of the canal and never used in the canal curvature. So again, low speed instruments, group 2 with a latch type attachment. These typical instruments in this group are gates, Glidden, burrs, and piezo rimmers. They are typically used in the coronal part of the canal and never to be used in the canal curvature. Only in the coronal, okay? Some people use them in the apex, that's wrong. Some people use them with the curvature, and also that's wrong. Group 3, engine-driven nickel titanium rotary instruments. They consist of rotating blade that can safely be operated in and adapt itself to curved root canals. Most engine-driven instruments available today belong to this group. And what are they used for? I don't know, but these are group 4. Group 3, and there are group 4 engine-driven instruments that adapt themselves three-dimensionally to the shape of the root canal. Like other nickel titanium instruments, they adapt to the shape of the root canal longitudinally, but additionally, they adapt also to the cross-section of the root canals. There is currently only one instrument in the group, the self-adjusting file. Self-adjusting file is the only instrument in the group 4 instruments. And I to repeat this, like other instruments, adapt the shape of the canal longitudinally and cross-sectional of the root canal. They adapt themselves to it. Then we have group 5, engine-driven reciprocating instruments, and group 6, ultrasonic instruments. We use ultrasonic to clean the canal, and engine-driven reciprocating instruments are also important. Let's start with the group 1, manually operated instruments, which is the barbed approach. They were the earliest endodontic instruments used to extrapolate the pulp. They are manufactured by hacking around tapered wire with a blade to form sharp, projecting barbs that cut or snag tissue. A barbed approach does not cut or machine dentine. This instrument is mostly used to engage and remove soft tissue from the canal. It is an excellent tool for removing cotton or paper point that have accidentally become loaded in the root canal. Again, manually operated instruments or barbed approach. It's not K-file, not H-file, they are only barbed approach. Earliest endodontic instruments to be used to extirpate the pulp, to extirpate the pulp. What's the meaning though of extirpate? Extirpate meaning to take it off. And they are manufactured by hacking around tapered wire. It is not round, not square, not horizontal, not square, not rectangular. And they are manufactured by hacking around tapered wire with a blade to form a sharp projecting barbs that cut or snag tissue. A barbed approach does not cut or machine dentine. This instrument is mostly used to engage and remove soft tissue, and they don't, again I will repeat, a barbed approach does not cut or machine dentine. Some instruments that we will talk later from the group 1, manually operated instruments, they do cut dentine, but this one does not cut dentine. And this instrument is mostly used to engage and remove soft tissue from the canal. As we said, extirpate the pulp, and it is an excellent tool for removing cotton or paper points that have been accidentally become lodged in the root canal. Next, the K-type instruments and the K-reamer. Both are the oldest useful instruments for cutting and machining dentine. They are made from stainless steel wire that is ground to a tapered square or triangular cross section, and then twisted to create either a file or a reamer. File has more flutes per length unit than a reamer. per length, flutes per length, and the K-type file or the K-type instruments are useful for penetrating and enlarging root canals, and they are coming from the triangle or coming from the square or trapezoid. These are called the K-type instruments and reamers. The K-type files has a cross-section that is rhomboidal in shape. This is the K-type flakes. It's not like the one that we discussed before. That was triangular. Neither it was the one with the square. And this rhomboid has a cross-section that is rhomboid. It's a twisted instrument and has a series of cutting flutes. It has two acute edges and two obtuse edges. The acute angle cuts into the dentine, while the obtuse angle provides more area for debris collection and removal. Again, the acute angle cuts into the dentine, while the obtuse angle provides more area for debris collection. The cutting efficiency and flexibility greater than the K-type file. These are the K-type file, and they are more greater than the K-type file with the rectangular, and this one is called the K-flex file. K-flex file is a twisted instrument, series of cutting flutes, and it's cross-section of the rhomboid. It's not a cross-section of the triangle, nor it is a cross-section of the cross-section of the triangle or square. This one is called K-flex. You have to differentiate between K-flex and K-file. Next, we have the flex O file, not the flex K-file. This one is the flex O file. This instrument resembles the K-type files, but it is triangular in cross-section. There is better cutting action and more room for the debris, better flexibility and more resistance to fracture. The tip of the instrument is non-cutting, so no apical ledge formation is possible. Okay, we have to understand this, everyone. K-flex files, flex O files that has no cutting edge, no cutting ledge, so it will cause no ledge, and it has more resistance to fracture and has better action for cutting and good room for debris. The tip is not cutting. Next is the H-type instruments, not the H-flex. It is not the H-file. It is the H-type. H-type instrument has a spiral edge arranged to allow cutting only during a pulling stroke. Cutting only during a pulling stroke. This one is called the H-type. An example is headstrom file. An H-type instrument is better for cutting than a K-type instrument. Again, H-headstrom file has an edge arranged to allow cutting only during a pulling stroke. What is called headstrom? It is similar to the one we discussed before, barbed approach, the first one we talked about, but this one is headstrom instrument, only cutting when it's taken from the root canal. This one used during a pulling stroke, and a spiral edge allow cutting only during pulling stroke. An example of headstrom file is an H-type instrument, which is better for cutting than K-type instruments. So which one is better? Is the H1 is better for cutting, or K? K is used during filling and pulling, but this one is only during pulling action, and has a better cutting than K-type file and K-flex file because it has a more positive rake angle on the blade with a cutting rather than a scraping angle. Next, bending a headstrom file results in points of a greater stress connection than occurs with the K-file instruments. These concentration points can lead to the propagation of cracks and fatigue failure. Heads from file are formed by grinding a single continuous fluid. This is why we do it only with pulling action, and it is very susceptible to break if we use it and bend it. Modes of action of intercanal instruments. What are the modes of action of the intercanal instruments? We have many modes of action, some as reaming, filling, quarter turn, circumferential filling. Let's start with the reaming action. Reaming action is a repeated clockwise rotation of the instrument, which will shave the canal walls and give a cross-sectional preparation approximately round. Reamers are usually more effective for this function. Again, reaming action is a repeated clockwise rotation of the instrument, which will shave the canal walls and give a cross-sectional preparation approximately round, and reamers are usually more effective for this function. We use reamers to do this shaving of the walls. Filling action, it is a push-pull action without rotating, which has a great efficiency, which fills with files. It's a push-pull action without rotation, which has a greater efficiency with files than reamers. The cross-sectional appearance of the prepared root canal is irregular with a general oval configuration, so the canal must be filled with gutta percha. Again, filling action is a push-pull action without rotation, which has a greater efficiency with the files than reamers. The cross-sectional appearance of the prepared root canal is irregular with a general oval configuration, so the canal must be filled with gutta percha. So the canal, it has to be filled with gutta percha anyways, but the filling action, the cross-sectional appearance of the prepared canal is irregular because it's oval configuration with the filling action. Next, a quarter tone filling action. This action is a combination of reaming and filling action. The instrument is inserted in the root with a quarter turn rotating 90 degrees. This one only 90 degrees, that means only quarter, like not full rotation, just a quarter rotation, then removed with dragging motion to produce an oval cross section. K-file and reamers are to be used. So when you insert it, you have to pull it and turn it, quarter turn, and when you remove it, you don't have to turn it anyways, to produce an oval cross section. And K-files and reamers are both good for this action. And it's called the quarter turn filling. The next and the last filling action is called the circumferential filling. And in this action, filling or quarter turn filling action is used with emphasis placed on the outstroke. So the filling is dragged along different sides of the canal walls with each withdrawal. The resultant canals has a wide orifice with a greater taper. So when you insert the file or the reamer, you have to turn it quarter degree. Then when pulling it, you have to go to another wall in order to do a circumferential filling, making and widening the walls of the canal. Thank you for listening, and you have to be enjoying this lecture and understanding it very well. Very important lecture and very interesting.